So hello and welcome to this future music video on the Toppobrillo Sport Modulator. I'm using it here as a dual filter, which probably isn't the first thing you thought of when you've seen the module. But that's what it's doing here. Let's check out a bit of what's to come in the video before we break this down, get into this kind of amazing patch programmable way of working, very Surge inspired, and then we'll get into some patches. So this is the Sport Modulator from Toppobrillo, a deceptively simple module that's very Surge inspired. It's patch programmable, meaning that by patching we define how this works. There's no menus, it's not digital, we're not kind of flicking through different functions. It just does what it does depending on where we put the cables in and what kind of signals we put in. It's 2 channels with an input, an output, an end of output, which you can think of like an end of envelope or end of loop, end of cycle. If this is being used with audio at the end, we can use this as kind of square wave generator. Has a rate control, which also serves as a lag or a filter, a slew, a portamento. We can smooth off edges in either audio or CV. We have a CV input and attenuator. It will self-cycle, which you can see on the LED, and that's the rate. Have a mode where we can use it like a sample and hold. The second channel has the same functions, and we get this comp output that's always comparing the 2 channels and will give us a gate high depending on the state of those 2 channels. So rather than try and kind of really explain it beyond that, we're just going to get into some patching and show you this patch programming and all the different things it can do, or at least some of them. We'll scratch the surface because it's kind of never ending, and we love this deep exploration that Modular gives us, and the Sport Modulator is definitely ripe for some really deep modulation. So let's get stuck in. So at its core, the Sport Modulator is a lag processor or slew generator, and this will take off hard edges and smooth out changes at the voltages at the input. At audio rates, that would be a low pass filter. You can think of low pass filter in a square, right down to a more sine-like waveform. That works at LFO rates and sub-audio rates as well. So this green trace on data is my input coming into the Sport Modulator. The blue trace is the output. And this is currently just modulating a bandpass filter. As I reduce the level, we'll start to introduce some slew and lag, rounding off these edges through a kind of clipped sine to an almost triangle-like wave. So listen and watch this blue trace as I increase the lag. You can hear it's not a hard change anymore. And there's a much smoother wave. There are a couple of tricks though to do some wave shaping with this, and this is this kind of patch programming the nature of the module. So if I take the end of output, I'll just show you what that does first by turning on the yellow trace on data. You can see that as it's finished its lag, we're getting a high output. Turning that off and plugging that into the CV input, so feeding the end output back to CV, the lag processing, and turning it up, we're almost getting envelope shaping, where it's got a faster attack time, a hold, and then a longer decay or release. It's like a ASR, attack sustain release. So we can see instant up, hold, and decay. If I patch the output back on itself, so just remove that briefly, put the stackable in. Here's the signal exactly as is, and then as I turn the CV up, You see we're getting quicker, faster exponential rises. It's a bit of a balancing act between the lag time and the CV feeding back on itself. We can actually process these linear triangle-like lag or slews into these exponential rises. So if we do this with audio at the input, we can use this like a low-pass filter. So here's an audio rate ramp wave, this green trace on data coming into the Sport Modulator. And as I increase the control, effectively decreasing the lag time, we get a low-pass filter style effect. So instead of rounding off square edges at lower sub-audio CVs, like that square wave LFO, you can almost treat this like a low-pass gate. We're filtering the audio down to nothing. So we could plug envelopes in, get some nice enveloped low-pass filter style effects. Let's add a bit of folding to the input wave. We could come out of the end output instead. And look at this crazy kind of PWM nastiness that we get. Just remove the CV. If this was a simpler wave, just a normal ramp again, it's all of a sudden a PWM generator. So turning up the modulation, we're getting PWM modulations over this pulse at the square out. At the same time as we get low-pass filter style effects at the main output. So I've hit cycle on the bottom channel of the Sport Modulator. The main output is giving us a triangle, this is the green trace on data, and the end output gives us that square. Now the rate of that wave is determined by the main control. We can CV it, we can gate it on and off, or actually turn on the hold mode and do some sample and hold tricks. Cycle turns the cycling off. But first let's look at wave shaping. If I patch the end output back into the CV input, and again we're just listening to the main out, the main triangle, end output into CV. It bends that wave round to a saw. There's a bit of pitch change as we do it. It actually skews that wave round to being a saw. So that's kind of wave shaping trick number one. Patch the output back on itself, and I'll just do this with a stackable cable. Just going to increase the rate slightly. We get a decrease in rate. We get these new kind of exponential spike waves. The linear sides of that triangle have been bent in to be an exponential rise and exponential fall. The kind of extreme of that dip and curve is determined by the amount of modulation from itself on itself. Crackly cable. So that SH input, when we're not actually in the hold mode, will function to gate this on and off. And I'm using an LED cable, so you can see when I turn up my offset on a separate module, just turns off the wave. Now I could set the top section cycling and do this at audio rates. We get kind of sync-like, kind of downsampled effects. But another thing we can do is CV input to actually FM this. And again, we'll do it from this square wave. Much slower. Nice obvious effect. Turning the rate up. For FM, softer waves tend to work well, so let's take the main triangle out. Of course, we could do all these with this functioning at lower rates. If I simply just turned it down to be an LFO, it just becomes an LFO that we can wave shape and control anything else in our patch with, or patch it back into the other channel or itself to shape and make more complex patch programmable functions. So here I've hit the mode switch. Well, turning it off is pretty cool too. So that I'm in the hold mode. And this blue trace, which is just a fast looking square on the data, it's this pulsing LED cable, is triggering a sample and hold. There's no input, but it's currently cycling. So it's sampling its own cycling self. So it's cycling as this triangle wave signals because it's sampling it. It's sampling and holding this signal. This is actually coming out to FM a bandpass filter. If I slow this sampling rate down, and it's taking data a while to catch up, but you see every pulse of this LED again, this kind of staircase waveform. If I slow this down, the cycling triangle, and say up the speed of the clocking, we're getting various sample and hold effects. Now turning cycling off and just putting noise into it, turning that up because this is now a lag processor when it's not cycling. I don't want to lag, slew or filter the noise. I mean, we can, but it's less of an effect. So turning that lag off effectively. It's randomly sampling the noise and giving us this sample and hold. Now we can use this as an audio downsampler. So let's just have a quick repatch and get into that. So here we're going to use the sample and hold as an audio rate downsampler, an effect that's commonly found on bit crushers. However, bit crushing works in the amplitude domain. Downsampling works in the time domain. Think of sample rate against bit rate on a CD or audio file. Here's my signal that's coming in, a simple ramp wave that's coming to the input of the Sport Modulator. And I'll just patch that so we're listening to the output of the Sport Modulator. Now if I turn this hold off, the audio passes through, and we can filter it as we've already seen in the video. But patching in an audio rate clock, and this is tied right up full, this will gate on and off, but in that hold mode, as I reduce this clock, we get downsampling style effects. This still works as a lag or for audio filter. And with my input wave staying completely static, we can still have a lot of fun sequencing and modulating this. If I had a sequence to my clock source, audio rate clock source, so that's affecting the speed of this signal that's clocking the S and H sample and hold input. And then say I drop the filtering and patching an envelope to CV. This is using an envelope to open up this filtering, and I'm sequencing my audio rate clock source. The input wave's static, but we're still getting some interesting sequenced modulated signals. So in this patch, we've rather amazingly been able to rebuild a surge random source module. Now here's an image on screen, a kind of classic of the modular synthesis world. So let's just unpatch a little bit and go through what is going on. I'm just going to turn off the audio for a second. Have an input, which is just a noise source, and then the output in its current state is my stepped modulation. It's this top trace on the Modax data, the green one. I'm patching the comp output into the second channel. I'm splitting the end output of the second channel for my random triggers, my random gate source, and I'm also using this stat cable, as I said, to split it back into the sample and hold. It's in the hold mode on the top channel. So as this end fires, it's going to sample the noise and give us this random out. And the comparator that's giving us a gate output, depending on the state of the top and bottom channels, is what's giving us these random triggers. So unplugging the stepped CV, here's the random gate turning on and off this oscillator. Now what was usually lag time is now a rate of random gates. We get a new random value every time this fires because it's patched back into itself. So let's patch up some modulation and pitch changes. And it's a great mix of stepped signals and some downward slews as well. I patch this into pitch, making the effect really obvious. So random CV, random gates. You can slew and lag that noise. You could CV the rate to CV the rate of this random gate, which is driving the whole patch and the kind of feedback that's given us this surge random source circuit. And that might just fend off a little bit of surge gas for a while. We should say you could of course use these random gates in context with some logic or some beats or a more modern musical context if you wish. The random CV could be like a nice humanized function on pulse width modulation or filters. It doesn't have to be this kind of retro sci-fi random modular synth sound. It's just a way of demoing these functions. So in this final patch, I'm taking both outputs and using their modulation that you can see on data to modulate two digital oscillators. I'm patching the end out to CV the top one, I'm patching the output of the top one to CV the bottom one, a little bit of feedback on itself as one modulates the other that then modulates the first one that then modulates the second one and so on. I'm going to play around with the settings, the CV amounts and the actual manual rates of these cycling LFOs, getting this quite nice chaotic, alive, organic kind of modulation from it. We've really just scratched the surface of the Sport Modulator. There's a ton of things it can do. So that's the Sport Modulator from Toppobrillo. We hope you found this video useful, and please check out other Future Music Magazine videos at the link in the description.